Master the fundamentals of motion with this video on distance-time graphs. We'll cover everything you need to know for your GCSE Physics revision, from reading axes to calculating speed. What is a distance-time graph? It is a key tool in GCSE Physics that shows how an object's distance from a starting point changes over time. By analyzing the slope, you can determine how an object is moving without needing extra data. To read a graph, look at the axes. Time is plotted on the horizontal x-axis, usually in seconds. Distance is on the vertical y-axis, measured in meters. Remember, time on these graphs always moves forward. Always check your units. Distance is in meters, time in seconds, and speed in meters per second. Mixing these up is a common exam error, so take a moment to verify your units before calculating. The most important rule: the gradient, or slope, represents the speed of the object. A steeper line means a greater gradient, and therefore a higher speed, while a shallower line indicates a slower speed. You can calculate speed using the formula. Speed equals distance divided by time. On a graph, this is finding the gradient using rise over run. Simply pick 2 points on the line, find the changes in distance and time, and divide. There are 4 key line types to recognize. A steep straight line is fast. A shallow straight line is slow. A horizontal line means the object is stationary, and a curved line indicates changing speed. A straight line on your graph indicates constant speed. Since the gradient doesn't change, the object's speed remains the same. You can use the gradient formula on any straight section to find the exact speed. A horizontal line means the object is stationary, with a speed of 0. Do not be fooled into thinking this means the object has moved backwards. It simply means the distance from the start is not changing. When comparing 2 lines, the steeper one represents a higher speed because it covers more distance in the same amount of time. Remember, steep equals fast, shallow equals slow, and horizontal equals stationary. Curved lines show changing speed. An increasing gradient means the object is accelerating, while a decreasing gradient means the object is decelerating or slowing down. Acceleration creates an upward curve that gets progressively steeper. This represents the object covering more distance in each equal time interval, such as a car pulling away from a junction. Deceleration appears as an upward curve that flattens out. As the gradient decreases, the object covers less distance per second, eventually reaching a horizontal line as it comes to a stop. Use this summary as a reference for your exam. Every line shape has a specific meaning, so always explain what the graph reveals about the object's motion when asked. To describe motion in an exam, break the graph into distinct sections. State the shape of the line, what it means for speed, and calculate numerical values if required. Good luck with your revision. Let's look at a practical example. This graph shows a student's 3-part walk. By breaking it into sections, we can calculate the specific speed for each part of the journey. To calculate speed from a graph, follow these 4 steps. Select 2 clear points, find the change in distance, calculate the change in time, and finally, divide distance by time. When in an exam, draw a large right-angled triangle under your line. This makes your gradient calculation clear and helps you earn method marks, even if your final result is slightly off. Avoid these common traps. Don't mix up your axes. Always remember to convert units like minutes to seconds, use the correct gradient formula, and make sure to describe every single section of the graph. Precision with units is essential. For distance-time graphs, ensure distance is in meters and time is in seconds, so your calculated speed is correctly in meters per second. Refer to this conversion table if you are ever unsure. Multiplying or dividing by factors like 1,000, 60, or 3.6 will help you keep your units consistent for your final answer. This slide breaks down a full, multi-phase journey. By analyzing each phase, you can see how an object accelerates, maintains speed, stops, or even slows down. Remember this core concept: the gradient of a distance-time graph is equal to the speed. It is one of the most frequently tested principles on GCSE Physics papers. When comparing 2 objects, the steeper line indicates higher speed. If lines cross, both objects are at the same distance at that specific moment in time. Curved lines on your graph provide specific details about acceleration. An upward steepening curve means the object is speeding up, while a flattening curve shows it is slowing down. Looking at acceleration and deceleration side by side helps clarify the difference. Both appear as curves, but notice how the direction of the curve determines the object's change in motion. It is crucial not to confuse distance-time graphs with speed-time graphs. In a distance-time graph, the gradient is speed. In a speed-time graph, the gradient is acceleration. Beyond the classroom, these graphs are used in fields like transport planning, sports performance analysis, and GPS technology to track and manage real-world motion. Let's walk through an exam question. Notice how the cyclist's journey is split into sections, allowing us to determine both constant speeds and identify when they are stationary. Finally, test your knowledge with these 5 practice questions. Reviewing these will ensure you are ready for any distance time graph question that appears on your final exam. Let's review the answers to your practice questions. For question 1, divide the distance of 90 meters by the time of 18 seconds to get a speed of 5 meters per second. Always state your units clearly. In question 2, the graph shows a horizontal line. This means the object is stationary, so its speed is 0 meters per second, because the distance from the start isn't changing. For the third question, object A is moving faster than object B. Remember that a steeper gradient on a distance time graph directly represents a greater speed, as it covers more distance in the same time. Question 4 identifies an object that is accelerating. An increasing or steepening curve on the graph shows that the speed is rising over time. For question 5, always remember to convert your time units. If your time is in minutes, multiply by 60 to get seconds before you use the speed formula. This glossary summarizes the key terms you've learned. Keep these definitions for distance, speed, gradient, and acceleration handy as you continue your revision. Use this checklist to ensure you've mastered the basics. Remember, axes must never be swapped. The gradient represents speed, and you must always check your units. When in the exam, always state the rule gradient equals speed first. Use large triangles for your calculations to reduce errors, and always include units to secure every possible mark. Remember the golden rule. On a distance time graph, the gradient of the line equals the speed of the object. This is a fundamental concept for almost any physics exam. Finally, this overview shows how these graphs link to other topics like velocity and force. Understanding these connections helps you see the bigger picture in your physics studies.